Today we're going to be holding both product and technical training for the Alpha ESS residential systems. That is the Smile 5, which is the 5 kilowatt system, and the T10, which is the 10 kilowatt three-phase systems. So Brian is going to be the one that is going to take us through the training. So in the meantime, I think maybe as ground rules, he is going to run through the whole training slides. If you've got any questions while he's presenting, just put them on the chat window. I will respond to them. And then if you've got other questions that you want to interact with even further, just jot them down. And then we are going to respond to them as soon as he finishes the training. So Brian, it's over to you. I don't know if you can share your screen.
Good day, everyone. Let me quickly share my screen. Right. Good day, everyone. Can you see my screen?
We do solar retrofit pieces using QuickGuard.
Yes, we can. We can see your screen. If I can ask everyone else to just mute their mics while the presentation is going on. Thank you.
Yeah.
So today we'll be looking at another residential product range that we offer, which is an Alpha ESS. So basically, we'll go through product overview, installation, commissioning, and troubleshooting. So firstly, we'll look at the Smile 5 product. So this is basically what we'll go through the presentation. So our first product that we'll look into it's a Smile 5. It's a 5 kilowatt hybrid inverter, which means it can actually utilize your PV both for critical and non-critical loads. That is, those high power inductive loads that are connected before the inverter grid input. So the inverter is a purely hybrid inverter. It comes in with so this is basically how it looks like. The top part is the inverter. It's combined with a cable box. So the cable box, basically, that's where you do all your connections, your battery connections, your comms cables and all that. And also on the cable box, you come with pre-installed protection and isolation devices. So you get your breakers pre-installed. So with this system, there is no need for extra protection and isolation for the of the DC and AC inputs together with the outputs as well. So and then the two modules below, those are the battery modules. They're basically designed for a Smile 5. So the system it's a plug and play system. Everything is pre-configured from the BMS. There is no need for you to get different cables and all that. It's a matter of setting it up and just plugging the right cables at the right place. All cables are provided with the system. So the Smile 5, they designed based on these 5 key points. The system is self-sufficient. It has a modular battery, which can be you can connect these battery modules up to 6 modules, and then the system has a as intelligent control.
Sorry to disturb you, Brian. There's a request for you to switch on your camera so that the participants can see you when you're presenting. Thank you.
Okay, just let me quickly do that. Okay. Can you see my video now?
Yeah, we can see you now. You can continue. Thanks.
Okay. So we'll basically look into all these these functions in detail. So the first one being the S self-sufficient. So the system it has built-in MPPT, which can take up to 6.6 kilowatt PV input, which can actually help to oversize your system in terms of your PV array. So the system, it has built in two MPPT, which takes in 2 strings with a minimum DC voltage of 125 volts to 550 VOC. So we can simply wire your strings. As I've said, the system has already built in protection and isolation devices. So you just need to wire your panel, your strings straight from the panels to the inverter. The connection mode, it's an MC4 connector, and the current rating for the MPPT, it's 11 amps. So it means all panels in a string, they should be in series, so as not to overload the MPPT. So the system, it's a 5 kilowatt single phase nominal power on the backup side. So loads connected on this port, they have to be within 5 kilowatt, regardless whether your source of power is grid, PV, or batteries. It can only support up to 5 kilowatt single phase on its backup side. However, on the non-critical side, you can have as many loads as you can. The inverter, it will simply supply those loads when it has excess PV. We'll also look into that on the operation modes. It is an integrated 100 amp DC battery charger. So it can utilize your PV, and you can also use your grid to charge your batteries in cases where you have an upcoming load shedding and the radiance is quite low. Then you can quickly set it to charge from the grid. We'll also look into those settings in detail. It's a 5 kilowatt single phase, so you can back up your system with a 5 kilowatt with uninterrupted power supply. The inverter has a 20 millisecond changeover when it loses grid. And then so the system operation, when it gets your PV, the priority will be to supply loads. So at first it supplies all the loads, both critical and non-critical. If there is excess, then it charges your battery to 100%. When your battery is full and you are licensed to feed back to the grid, then if there is excess, then you can feed back to the grid. So the grid works as a standby to the system, more of a backup to the system. So when the PV is low and the battery is low, then the system can use the grid to supply your loads or to charge your batteries. And then the second aspect is the modular battery. The battery that we distribute our alpha with, it's a 5.7 kilowatt hour battery, which has a 90% depth of discharge. So you can train it up to its deeper levels of 90%. However, you can, if push comes to shove, the battery can go up to 96%. But with the inbuilt BMS, it will always make sure it stops discharging at 90% whenever there is an alternative power source. So the 90% of 5.7, that's around 5.16 usable. It's a 48 volts with a 51.2 volt nominal voltage. And the C rating of the battery, it's a 0.5 C. So it means the battery can only supply constant power of 50% its capacity. So it means we have come across this situation in most cases where someone has an alpha system with one battery, and then when you are now on UPS mode without your PV, the inverter, yes, it can supply 5 kilowatt to your loads, but now the battery would limit because it has a 0.5 AC rating, so it can supply almost 2.7 to 3 kilowatt uh, power at a core. And it has a built-in BMS integrated, which is compatible with the Alpha system. As I've said, the system, it's a plug and play. Everything comes pre-programmed. So this modular battery, you can connect up to 6 modules in parallel. That's up to 34.4 kilowatt hour of backup. The operating temperature range, it's suitable for our region. It operates from 0 to 40, which is the nominal temperature. However, if push comes to shove, it can go up to 60, but we recommend to keep it to keep the environment within 40 degrees. If temperatures can go beyond that, there will be need to put an air condition to maintain the temperature below 40 for optimal operation. And then the next aspect is the intelligent control. The system, as I've said, it's a purely hybrid system. So it helps to maximize your PV consumption. So once the system, after it is supplied, catered for all your critical loads, that is loads connected on the backup, it can actually push power to those non-critical loads, that is the high power, the stove, the geysers, the pumps, through backfitting the grid point, thus helping to fully maximize your PV. And the system is supplied with a meter, a single phase meter or a 3-phase meter. So this meter will be installed at the grid incomer soon after your mains incomer, such that it measures everything in the house, because it's the one which is responsible for giving the inverter the set point to produce. So that meter would actually help the system to limit to self-consumption, that is to only supply load to your premises. If you are to fit into the grid, then the meter will actually tell you how much you are fitting back to the grid. So the system, as I've said, the battery is a 90% depth of discharge. So you can train it from 10 up to 100% on UPS, and it can actually export PV power up to the rating of the inverter. It's programmable. If you are to feed back to the grid, you can actually set how much maximum fit in you would like to push to the grid. It can feed back up to the rating of the inverter, that is 5 kilowatt. It has programmable charging and discharge control, which is a remote function through your app on your phone or through the website on your computer. If you have an upcoming load shedding and your battery is quite low, then you can quickly log into your monitoring account. Just set your time. It actually gives two timelines to set. You can actually set it to charge for the specific time zones. Then it will use grid to charge your battery to a programmable percentage. If you want them charged to full, you can set the battery to charge to 100%. If not so, you can set it to any percentage. The system is connected to a smart PV platform. I'll also show you that as well. It's quite a good platform with good aesthetics, so you can actually get to view your plant performance from PV production, load consumption, feed in, and you can actually get to see the fault logged remotely, and actually change some of the settings, except for safety settings, which is the grid code. You can only do that when on the unit physical. And then the alpha system uses the new technology. All know lithium battery, lithium storage technology is actually up the market. So it uses the technology, its advantages of long lifespan and bigger depth of discharge. So the system utilizes that technology. The battery lifespan is pegged at approximately 20 years at an assumption of 1 cycle per day. So with an assumption of 1 cycle per day, the lifetime of the battery can go up to 20 calendar years. And then the system, it is good aesthetics. You can just mount it even in the house. The system uses natural air cooling, so you won't get any noisy sound from the fans in operation. It's just a system that operates quietly. Looks like just like furniture in your house. It has good aesthetics. It's an elegant and slim design. Takes little space in your property. It has a flexible installation. You can actually install other battery modules by the side and all that. We'll also look into it in detail. The IP rating, it's for the system. They come in 2 forms. We have got an IP21, which we usually distribute. That is an indoor for the battery and the inverter. And then there is an IP65. If you require an IP65, which is an outdoor version, then you would need to notify your account manager. Then he can arrange that one for you. So as I've said, the system, it's a plug and play. All protection and isolation, they come plugged in. So there is no need for extra cost of buying breakers, isolators, and all that. You can simply wire your cable straight to the inverter. It eliminates all those all those accessories which are added to the initial cost. So the extra value that the system brings, the inverter, it's a pure sine wave. So it means it's compatible with our grid regulations, the NRS 97, and it's licensed, it's certified under the NRS 97-2-1, which is our regulatory grid code. And then the system offers uninterrupted power supply. The system can work as a UPS when you are watching your TV and all that. You won't even notice that the grid you are now on load shedding. It offers a 20 millisecond changeover. There is a backup box which is for our region. It's not yet certified, but it's something in the pipeline. I'm not sure on the specifics when it would be deployed, but it's something on the pipeline. With the backup box, you can utilize to set your battery to supply certain circuits up to specified battery SOC levels. And then the system offers auxiliary contacts, 2 channels, which you can actually use to control your external devices, switch on your generators or other relays and so forth. So those are digital inputs. And the system, as I've said, it has a free cloud monitoring. So when you buy the system, the package comes with it as a lifetime package. You can get to monitor your system at the comfort of your home. You can actually troubleshoot while you're at the comfort of your home, get to know what the fault is, just that when you get to site, it will be a matter of fixing, not to try and find where the problem is. The system, the inverter can be connected in parallel, although there are limitations to that. A max of 3 systems can be connected on a single phase. That is 1 inverter on each phase. And then on a single phase basis, you can connect up to 2 inverters. We'll also look into it in detail, up to 10 kilowatt. But once the inverters are connected in parallel, they cannot charge your batteries from the grid. And on a single phase basis, the two inverters would actually have two separate backup outputs. But on the non-essential sides, you would have a combined 10 kilowatt output. So for cloud monitoring, on cloud monitoring, you can actually get remote control of your system, set your discharge and set your settings for battery discharge, charging, and all other settings. And then the system actually offers a remote upgrade for the BMS and management through a USB or internet. The system, as I've said, you can actually change your settings on remotely, and the system has a built-in income calculation. So if you set your kilowatt price and all that for different tariffs, it can actually calculate your savings. If you had how much you would spend if you were to buy that power from your utility supply. So on the installation, the system is quite heavy, so it's recommended that the system sits on the floor or on a platform which can take much load. So the first, as you can see from our top left to the right, you have to sit your battery on the floor against your platform you're installing it. So we'll refer to your wall in this example. So you sit your battery on the floor against the wall with brackets provided. You mark your battery to the wall, drill 4 Fisher plugs or robots, then you install the first battery. In installing the second battery, you sit the second battery on top of the first battery, and then you just mark your points as well and secure your battery to the wall. And then the system is provided with a bracket for the inverter. So the bracket hooks on the battery bracket. So on your top battery, you just hook your bracket there and then mark your drilling points. That actually makes it easier for the inverter to be in line with the battery. So, and to put on the inverter, you just hook it on the bracket, and then and then it would hold firmly, supporting on the battery module as well. So so once you install your battery holder and fix it on the wall, and then you install another battery if you have 2 batteries, and then install the inverter bracket, as I said, and then you connect your cables, your battery cables, your internet cables, your battery comms cable, and then from there, then you would need to do a few settings on the battery, on the bottom battery or the last battery on the chain. You need to set deep switch number 2 on. You can access this deep switch port when you open the battery cover. There is a small plate there with 2 screws. So if you just unscrew that plate on the inside, there are 4 deep switches there. Then you would need to set the last battery deep switch number 2 to on. This basically notifies the BMS daisy chain that this is the end of termination for the batteries. And then there is, as I've said, the system is a purely hybrid, so it needs to constantly monitor your load and grid. So there is need to install a power meter at the grid incomer, and then you would need to run a communication cable. On the inverter side, it's an RJ45 plug-in. On the meter side, it comes with an RJ45 plug-in. But however, if the space where the meter is installed needs you to not to have that plug-in, you can just remove it and wire it as an RS485 connection. The conversion from RJ45 to RS485, they are provided on the manual. So this is basically how the inverter looks like. So this is the inverter. The undercover, which is the small strip cover on the inverter, it can be removed to access the cable box. So when you are facing the inverter, your cable connections, they are on the right for the grid and backup, and the PV. The PV that at the far back, and then the grid cable clamps and the comms cable clamps that are at the front. And then on the right side of the pic, there is a section which is circled with inverter, DRM, meter, LAN, and BMS. So the inverter point, when we are connecting inverters in parallel, that's when you use it to daisy chain your inverters. The DRM, we don't use because our battery comms is compatible with the CAN bus, with the BMS, which is the built-in. The inverter, however, it can take a CAN bus, but in this case, the system, as I've said, it's a plug and play. Everything is pre-programmed. So your battery cables, you are from your battery comms cable comes to the BMS. Your LAN, you are your internet, your premise internet for remote monitoring and control. And then on meter, that's where you are your cable from the grid meter. So to access this this section, you just need to unscrew this plate with those markings, and then you can access the comms ports. They are at the top of the opening, and then going to the left, there is an area where there are isolators and breakers. So you'd get two breakers, which is the backup and the grid. And then you get your PV isolator, labeled PV switch, and then you get your battery breaker, which is a big black, which is a written BAT abbreviation for battery. And then the power cables from the battery, they are connected on the left side of the inverter. It's a push and plug connection. The cables are supplied together with the inverter. So to set up the system, once you have installed, you need to connect your PV, which is 2 strings from your panels, taking note of the VOCs, 125 minimum, 550 max VOC, and then you have to connect your grid incomer. So the connection mode, soon after your mains meter, you would need to go through the alpha meter such that it measures everything in your premise. And then soon after the meter, then your live wire, then you distribute it to one end goes to non-essential loads. That is the non-essential distribution port, where usually you have your inductive loads, your high power loads, that is the aircons, the stoves and the geysers. And then the other cable from the meter goes to the grid point of the inverter. So this grid point inverter is also an input when it's feeding the non-essential loads. It's an output sorry when feeding the non-essential loads, and an input when it's drawing power from the XCOM to supply, either to charge battery or supply the essential loads. And then you need to connect your communication cables, LAN, Ethernet to LAN, meter to meter, LAN 2, which is the inverter inverter port for paralleling, and then the battery comms cap for the battery BMS connection. So this is basically one of our clients who was doing the installation. So I see the first battery, second on top of the first, and then that is the inverter bracket, and then you just hook the inverter on the bracket, and then it will rest on the battery. Now on the battery cables, the battery it's a parallel mode battery, so your positive is connected to positive, your negative is connected to negative. It has two ports. It has 2 connection ports, one at the top, one pair at the top, which is the positive and the negative, and then one at the side, on the sides, positive on the left and the negative on the right. Those points are the same. So from your inverter, from the top battery to your inverter, you connect your power cables from the top of the inverter, from the top of the battery to the left side of the inverter. And then to connect the top battery and the bottom battery, then you take from the sides of the top battery to the top of the first battery, and so on if you have more than 2 batteries. So to loop your batteries for the power cables, you take from the side to the top of the next battery, and so on. And the cables, the cable lengths are enough. Can reach your battery. Let's say if you want to connect other modules on the side, then the cables would actually are long enough to get to the termination points of the next battery if it's mounted side by side. So your bottom battery, or the last battery on your chain, if you have more than 2 batteries, you would need to set the deep switch number 2 to on the bottom battery. All other batteries, that is all the top batteries, they are all deep switches, you have to be off. So there's you don't need to set anything. And then on the last battery, or on the chain, or the bottom battery, if you have 2 batteries, you need to set deep switch number 2 on. So if you have 1 battery, so it means that's the bottom or the farmost battery. So you would need to set that 1 battery deep switch number 2 to on. So to access that, you would need to open the battery cover. You just pull it back, and then you access on there is a small plate with 2 screws. If you open that plate, inside you would see deep switches there. Then you just set deep switch number 2 to on. So that basically would give the inverter to like an end of termination for the battery such that you can know how many batteries are connected to the system. And then the meter point. So this is the meter connection from your grid incomer. You get into L and N, and then you go out of the meter at L prime and N prime to your grid point on the inverter, which is the L and the N. And then you need to ground your G on the inverter. And then for the comms cable, you would need to wire an RJ45 on meter point on the inverter. The meter comes with the RJ45 plug-in. It's a straight cable, 1 to 8 on either side should be the same. So you can wire it straight to the RJ45 plug-in. But in case where the RJ45 plug-in doesn't fit in your DP port, then you can just remove it and then take strand number 3 and 6 to 0.5 and 6 respectively. That's the RJ45 to RS485 conversion. So this is how the system looks like when installed. So for operation, most of the settings, they come pre-configured, but a few settings has to be set to the specifics of your operation. So the power on procedure, when everything is done and checks have been done to see that everything is wired and the inverter is properly grounded, you would need to open that small strip cover just under the inverter to access the control box. So inside the control box, you get your grid, backup, PV, and battery breakers. The power on procedure, you would first power on your PV array and put on your grid. One thing about this inverter, it's a hybrid inverter, and at the same time, it can be used as a grid tie inverter. So you can actually install the inverter without batteries and set it to operate as a grid tie inverter. So the moment you power on your grid and PV, the inverter would actually power on. So if you had to use this as a grid tie inverter without batteries, then you'd need to set the battery ready. We'll look into it when you're going through the settings to battery ready, yes, like to give it a virtual battery scenario, then it can operate as an off-grid. And then if you are if you are to use it as a hybrid or off-grid with a battery bank, then you would need to set the battery ready to know, such that the system you will know that it has to look for batteries and have a good comms with the batteries before it starts operating. So when you power on your PV and grid, the system will power on the LCD screen. And then from there, you can put in your battery breaker, which is inside the control box. After the battery breaker, then on the physical battery, there is a small switch there just above the battery indicator, the battery bar indicator. Just push it in, and then the battery would come on. The battery status indicator would come on and will flicker around to show that the batteries is connected. So if the battery is initializing, the outer ring would flicker at faster intervals once every second. And then once the battery is, after the BMS has done the checks and is communicating with the inverter properly, then the outer ring would flicker after about 10 seconds to show that the battery is ready and on standby. So that's the backup procedure. Once your battery is on and the system is now running, the system runs on 2 modes. The first mode is the normal mode. So on the screen, it will give a text return normal. In that case, it means it's running with grid. The moment it loses grid, that is on an off-grid situation. When it doesn't have grid power coming to it, it will simply run on UPS mode, which is basically providing an interrupted power supply from your battery and PV. So once your system is stabilized with normal or UPS, then from there you can put up your backup breaker and supply your backup load. So once the system is up, and then to access the operation function, the system is on the right side of the screen. It has 4 buttons: escape, enter, and up and down arrows for scrolling. So if you, from the home screen, if you press enter, you scroll down to settings, and then the default password, it's 4 ones. Usually we don't recommend changing the password, because next time when you want to do some changes and you forgot the password, that becomes a hassle. So usually prefer that you leave the installer's password as 4 ones. So you just type in, press enter, the arrow would move from password to the zeros where you need to put on your password, and then you'd use the arrows to scroll up the numbers. So once you enter settings, there are 3 functions there. We'll look into them one by one. We have the function, we have the safety, and then we have system restart. If you want to restart your system from the unit without physically switching off everything, you can give it a quick restart. And then we have system. So the first function setting that we'll look into is function. So in function, we have solar as our first function there. So on solar, when you press enter on solar, it will actually prompt you to input the amount of your PV array to specify your PV array that you put on the roof for the MPPTs. And then the other setting on solar, it will automatically pick the number of strings connected, and basically you just have to scroll just to confirm if it picked all the strings there. And then the next setting will be the battery. On battery, everything comes default. The system will automatically pick up the type of battery connected to it, the number of batteries that are connected in terms of capacity. So if you have 1 battery, the capacity will be 5 5.7 kilowatt, and then if you have 2 batteries, 11.4. So basically on the battery setup, you just need to scroll and confirm that the right capacity has been detected. If not so, then you need to check your if your deep switch number 2 on the left battery, if it's on, such that it picks all the batteries above that battery. And if you scroll also, there is an SOC calibration. You set it to no, such that you would prompt when you need to, the system will automatically, since it's a plug and play situation, the system would automatically calibrate the battery on its BMS. So there is no need for manual calibration of batteries whenever you power on the system. So it's default on no, so there's nothing to change there. If you intend to use the inverter as a grid tie inverter, that's where you access the setting of battery ready. As I've said, battery ready, if it's set to no, the inverter, it means it needs to be connected with batteries. But however, if the inverter is to be used as a grid tie without batteries, you need to set battery ready to yes, to give it a virtual battery scenario. And then the next setting after battery is grid. So usually on grid, it will automatically pick all the grid values, the power factor, the frequency from the grid it is connected to. The only major setting that we need to set here is the fit in. So if you access grid, go to select fit in control. It will prompt you for a user value, which is basically the maximum power in percentage of the inverter rating you would want to feed to the grid. By default, it's 70%. So you can set it if you are not to feed back to the grid, then you would need to set it to 0. If you wish to feed maximum power to the grid, then you need to set it to 100%. Then it will feed 5 kilowatt to the grid. And for all other percentages, to simply calculate as that percentage of 5 kilowatt. So you can set it to any preferred value, the maximum fit-in rate user value. And then the other major setting that you need to look into is the system operation. The system operates in 3 modes. The normal standard setup, it's called a DC mode, where you have your grid, your PV, only alpha as the inverter on the premises. It's called a DC mode. And then the next mode, we'll look into it in detail, the orientation of it as well. And then we have got the second mode, which is the AC mode. The AC mode, basically you'll be having 2 inverters, one inverter being a grid tie inverter, which is not alpha. Any other inverter or another other array of another inverters in a daisy chain on the system, which are grid tie or hybrid, then if you are not wiring any PV to the alpha system, is said to be an AC mode. But if you are intending to wire PV to the alpha system and you have another inverter in the system, then that system is considered to be a hybrid. We'll also look into the SLTs of these systems. So if you access any of the settings, you are prompted for force charge. So force charge is basically, if you enable it, it's charging from the grid. If you just enable the force charge and you do not set the times when you want to charge your batteries, the system will not charge from the grid. So when you enable your force charge, then it will give you more options to set your charge start time 1, start charge end time 1, start time 2, and end time 2. And then it will actually give you an option where you can set to what percentage do you want to charge your battery to. You can set it to, it's 100 by default, but you can set it even to say your grid can only charge your batteries to 50%, such that you can fully utilize the PV array to get your batteries to 100%. The system also can offers you a discharge mode. You can set the system to discharge at certain time zones. Let's say on peak times, charge your battery on your battery, and then when you have on peak hours, then you get to use the PV power during your peak hours. But with this setting, please note that when you enable discharge and set time zones, the inverter will only discharge the battery during that period. Regardless if it loses grid, that is when you have a load shedding out of those time zones, the inverter would not discharge battery because it's set to discharge battery on those specific times. And from on that work mode, you can actually select your UPS reserve SOC. This is the battery SOC that you would like to only use when you have a load shedding. So this value depends on which area you are, how erratic is your load shedding program. If you experience a lot of load shedding, definitely you need your battery to always have a high SOC to back you up when you're on load shedding. But if you're in areas where there is less load shedding, then you can set the reserve SOC a bit lower so that you can fully utilize your PV system. Use your, at night, off the sun, you can use your battery. When the sun comes up, charges your battery to 100%, and then you'd actually reduce your utility bills. And then those are the main basic settings on function. The next setting is the safety. Out of functions, underneath functions, there is current safety. To basically on safety, you set the grid code. The inverter is certified for our region, which is South Africa, which is the NRS 097. So you just need to select the country, scroll down for the grid code. So it will automatically set all the under voltage, over voltage, under frequency, over frequency settings as a standard as per NRS specifications and all the power factors and all that. So you don't need to set the grid settings manually. And then out of set, that's the only thing that you need to set on safety. And then out of safety, there is system. On system, basically you set basic parameters, you set your date, your time, and then there is an Ethernet settings. So on Ethernet settings, you can actually set the system between DHCP, which is automatically the system to automatically pick up the IP address of the internet connected to it. However, we don't recommend static setting to static, but if there is need to, you can change the IP mode to static. Then you would need to manually set the IP address, the subnet mask, and the gateway for the internet that you're connecting to the system, such that the system can access the alpha server for remote monitoring and control. On basic, you can set your language. It comes with two languages, which is English and Germany. So it usually comes with default English. So I'm sure if you feel like you wanna use Germany, you can select Germany. And then there is information which basically stipulates the system information, the serial numbers and all that, and and MAC addresses. So usually you just check if your system serial number corresponds with the serial number on the outside of the inverters, which never happens. It's always the same. So we'll quickly go through the work modes. As I said earlier, the normal setup where you have your PV to the system, you have your battery, you have your loads, and then you have your grid. It's a DC coupling system. So on system mode, you need to set it to DC. When you have a second inverter on the system, and you are not intending to put in any PV to the alpha system, that system is an AC coupled. So basically from your DC mode, you would have your second inverter, which is called a PV inverter, and PV array will be wired to that PV inverter, whether it's an off grid or a grid tie. So the system can be retrofitted to existing systems. if the client has already a grid tie inverter installed and is looking for a backup system, then you can just get an alpha. There is no need to remove the existing system. You just wire it as an AC coupling. However, you would need a second meter, which has to be installed at the output of the PV inverter. So this meter is there to measure the output of the PV inverter. At the same time, make sure that the alpha system does not feed back to your PV inverter to avoid damaging your PV inverter. So that meter is essential for feeding back to the PV inverter, and also to calculate the output of the inverter. So now on the system you have 2 meters. So these meters are daisy chained together on an RJ45 or an RIS45 scenario to the inverter. And then if you have a scenario where you have to wire your a PV array to the alpha, and you have a PV inverter as well, that system is considered as a hybrid. But all the meter wiring and configuration, they are the same as that of an AC coupling. So you can actually maximum your PV. You have a grid tie inverter to supply the bulk of the loads, and then when you have a load shedding, the alpha system will be there to give power to your backup loads. That is the loads that are essential during load shedding. So please note that this PV inverter is not installed at the output of the alpha. It's installed on the grid line, like at the input of the alpha on the grid line. So when you have a load shedding, your PV inverter, if it's a grid tie, it will switch off because it won't give a grid reference, and the alpha would only supply loads connected on the backup. So this scenario is not a frequency shifting scenario. It's a basic AC coupling where you get two inverters on a system communicating, working independent of each other. So this is basically the SOD of it, of the alpha system. Basically everything that we've been talking about, where you'd have your grid incomer, you have your grid meter wired to the management system of the inverter, and then your internet wired to the management system as an on an RJ45 basis. You have your battery bank up to 6 modules in parallel, the comms of it daisy chained on batteries, and then wired to the management system of the system through an RJ45 cable as well. And then you have your normal loads that are wired after the grid meter, but before the grid input on the inverter. Those are non-critical loads, inductive loads, high power loads. And then we have from the inverter part, we have the output, which is the backup port, which you wire your critical loads. Please try and avoid inductive loads on the critical side because of their starting current. They can easily overload the unit when it's changing over to UPS mode. It's 20 milliseconds. So definitely the grid, it has to lose grid, and then inverter power comes on. During that that 20 millisecond period, if you have inductive loads, they will draw an inrush in current, that is starting currents, to compensate for the dip in voltage, and that could actually cause overload on the inverter. So if you have inductive loads connected on your critical load side, you would find yourself in most scenarios having the system restarting between waiting and checking continuously. And then you have your PV array, which you would wire straight from your panels. All panels in a string have to be in series. The MPPT current rating is 11 amps, wired straight to the inverter. So as I have said, as you can see, the dotted lights is the inverter. So there is no need for external isolators and protection devices. The system already has a built-in protection from overcurrent, string, reverse string current, earth leakage. The inverter is a built-in 30 milliamp earth leakage device. So when it gets all those errors, it will actually log them and notify you on the portal on the physical unit under status. You can actually access your error logs there as well. So this is basically an AC coupled setup where you have a PV inverter. So basically you would have your PV inverter and then your PV meter wired daisy chained with the grid meter to the management system, and then the all other setup will be the same for that of DC, except that for AC coupling, the alpha will not have PV installed to it. And then for the hybrid system, this is the SLT. You have your PV inverter, PV meter, daisy chained with grid meter, and then you have PV to the PV inverter, and then you have another PV array direct to the alpha system. So this is basically the SLT for it. So the work mode, when your PV is greater than your battery and load, that is, as I've said, the system, when it receives PV, the first thing it supplies your loads. After supplying your loads, it charges your battery. After charges your battery, it feeds back to the grid. So when your PV is greater than battery and load, it will supply your load, your battery, and your grid. If PV is equal to the battery and load, that is a scenario where you're not fitting back to the grid. So the system would only supply your loads and charge your battery, and nothing will be fed back to the grid. If your PV is equal to the load, the system takes priority to supply your loads. Or so the system would actually use your PV to supply your loads. When your load is greater than PV and battery, that's basically when your PV is less than the load consumption. So the system would use your PV, supply your loads. The deficiency it takes from the battery to depending on the battery rating. If there is a deficiency of again, then it will take power from the grid to supply your loads. When your battery, when you have grid and your battery discharges to the set SOC, reserve SOC, then the system would use PV and grid to supply your loads, and the battery will be kept only to be used when there is a load shedding. So when you don't have PV and the battery it's less than load, so the battery rating, whatever it can supply, if it's less than the load, then the system would use whatever it can get from the battery, and then the excess of it, then it takes from the grid. That is usually on night scenarios. When the PV is less than the load, and the PV and the load is less than the PV and the battery, that's basically a scenario where your battery can supply your loads and the PV. So you'd get all of your PV pushed to the load, and then if there is a deficiency, then it's taken from the battery to supplement the load. And then so if you don't have grid, you don't have PV, that is in a load shedding scenario at night, then you get your battery supplying your loads. That is only your critical loads connected on the backup port. So these are the different work modes. When you don't have grid and your PV you have excess PV, then the system will supply your loads, charge your battery. If you don't have grid and you get your system to use PV and supplement your critical loads with the battery as well. And then the system, you can actually set it to charge from the grid. So when it's charging from the grid, the system would use your PV to supply your loads, and then it will use the battery to charge the grid to charge your batteries. Or depending on the battery SOC, it can use the PV to charge your battery and supply your loads, and then the deficiency of loads, then it's supplied by the grid. So these are just different work mode scenarios. As I have said earlier, the systems can be connected in parallel. For a three-phase scenario, you are limited to one inverter per phase. That is, you'll be having basically a 15 kilowatt three-phase system with peak power on each phase being 5 kilowatt. So your neutral is common in a three-phase scenario, so it's wired to all inverters, and then each phase to each inverter. And then you only need one meter, which is a three-phase, and then it's wired to your first inverter, which is your master inverter. And then from the inverter, then you daisy chain your inverters from inverter 1 to inverter 2 and 3. However, you would need an RJ45 coupler, which would couple your master inverter to the other two inverters. So basically, you need the switch, and there is the cable used. It's a type B. So this is the cable orientation. How you should crimp it. It's all this information is supplied with the manual. So basically, with a three-phase situation, you'd have your system with three inverters on each phase, and the system can actually produce a three-phase power at a standard phase angle, and it's standard phase angle, and each inverter can load can overload separately. If one inverter overloads, the whole system shuts down since it's operating as a three-phase system. And then the second scenario, it's paralleling in a single phase. So you can parallel up to two inverters on a single phase. However, so it means your live and neutral is common to both inverters. On the power side, you would need only one meter, a single phase meter or a three-phase meter. And then that meter is wired to the master inverter. And then the inverter is daisy chained to the slave inverter through those RJ45 components that we spoke about. And then you would need to activate parallel mode on the inverter settings. On function, you need to select parallel and specify whether the inverter is a master or a slave. But the backup side of the inverter is separate. So it means you would have two separate DP ports for your backup for the inverters. But the non-critical side, which is the loads before the inverter, as you can see, the grid and the live and the neutral are common for both inverters. So you basically have a 10 kilowatt backup on the non-essential sides, and then you would have a 2x5 backup system on the backup side. Please note, when these systems are connected in parallel, grid charging is not possible. You cannot charge your batteries from the grid. On troubleshooting, these are some of the common faults that usually come on the inverter, and the probable cause and troubleshooting recovery for them. So this mainly the faults, they are just general solar industry faults, UPS overload, which have meter two fault. The one distinctive is the meter two fault. So basically, if your system is wired as a DC setup, you only need 1 meter. So you would need to set it to DC. If you set it to AC or hybrid, then the system will search for the second meter and give a meter two fault. And then if it just gives a fault, meter fault or CT meter fault, simply it means it has grid power. It can actually detect the 220 volts on the inverter. However, it has lost communication with the meter. This usually installers would mix power cables and comms cables together through to noise and all that. You might get this fault coming more more oftenly because of that. So usually when you run your comms cable, please run them separate from power cables to avoid continuous disconnect of the grid meter. And on the initial install, when it gives this fault, usually check if your cable is correctly crumpled and if it's correct, it's wired to the correct port. And then when the system loses communication to the battery to give a BMS fault, and if the system loses the voltage from the battery, it will give a battery fault. So it usually gives an other device fault if the PV is abnormal. If you get if any of the strings short to ground, or the voltage is beyond, it's above the rating, or the PV voltage is erratic, it's spiking up and down, that's when it will usually give other device fault. You can also get this fault if your isolation, if your isolation, that is your grounding and all that of the system, gets your isolation resistance gets too low, you would actually get this low as well, this fault as well. So and then the battery has an LED indication.
Sorry to disturb you, Brian.
Yes.
While you're on that slide, I think we really have to emphasize that it's important to spec your system correctly, especially on the backup side. More often than not, most systems always get this UPS overload fault or this overload fault, because you find that some of the installers won't have spec the backup side correctly. So the system, Brian has already mentioned it, I'm just reiterating that on the main loads, the system can supply as much as possible, like even more than 5 kilowatts, if the kilowatts power grid. But on the backup side, the maximum is 5 kilowatts. So the lights and every other critical load that you connect there in total should not exceed 5 kilowatts. That's why we even discourage you connecting things like the pool pump on the backup pump starts, it spikes and it exceeds 5 kilowatts, and then the inverter trips on an overload fault. So that I thought that we should fault that we come across. Thanks. You can continue.
Yes. Yeah. Well, yeah. Like what was said, in most cases, it gets frustrating when
you can continue, Brian. It's okay.
Okay. So the battery has an LED indications which shows the battery status, like in terms of it's on 20% graduation. So when the battery has an error, error indication is displayed on those battery status page. So for different orientations on the of the battery, it displays a different error. As you can see here, I've got 11 errors. So if the outer ring that I said earlier, it will be flashing green once every 10 seconds when the battery is communicating well. If it changes to red and it has only one bar, it means the hardware error. And then if it's depending on hardware error and all that, it records those 3 error codes. So usually if you get that in scenario, you need to contact us, and then we can quickly check. Since the system is monitored remotely, we can actually check remotely what could have caused that fault and advise on the possible recommendations to it. So for different faults and all that, different status bars are short. So you just need to refer to the manual to see what kind of error you are getting, and also contact us to assist on that. So that is basically much of it regarding the SMART 5, which is the 5 kilowatt single phase inverter. And then we'll quickly jump into our second product range for Alpha, which is a 3 kilowatt system, a T10. It's called a Storion Smile T10. So this is a 3-phase inverter. It cannot be paralleled, so it comes as a wall unit. The battery modules to it, they are different to that of Alpha. It's a high voltage system. It utilizes the high voltage system, so the batteries are connected in series. So this is the aesthetics of it, how it looks. Also, it uses natural cooling. It doesn't have fans, doesn't make noise. It's a silent machine which you can actually install in your house, and you won't get funny noises that would disturb your sleep and all that. So it's just like a SMART 5. It's a self-consumption unit, a purely hybrid inverter. So it can actually supply your backup loads, your non-critical loads, charge your battery if there is excess PV, push to the grid if you are allowed to, and the setting for grid fit in, you need to set it on the system. It offers UPS, just like Alpha, a 20 millisecond changeover. Modular design. You can connect up to 8 batteries on this system. Also comes in IP21 and IP65 rating. We normally distribute the IP21 since it's a residential package. But if you intend to install an IP65, as I've said, you need to contact your account manager. He can arrange that for you. And then it's a plug and play scenario, just like the SMART 5. All pieces, they link up together. All cables isolation, they are inbuilt. Easy installation, low maintenance. It has a screen for 24/7, just like Alpha. It has a display screen for 24/7 local monitoring and interface, and you can connect it to Alpha Cloud for remote monitoring and control, just like the SMART 5. It is a plug and play. As I've said, it's a plug and play. The EMS, the BMS is pre-programmed, so you just need to just put the pieces together and get it going. It's a 3-phase. It would need a meter. It's a hybrid inverter. So if it's connected to grid, definitely you need a meter, a 3-phase meter, and the comms cable will be wired to the inverter. So the meter comes either as a pass-through meter, that is all power passes through the meter directly, or as a CT meter. You can actually wire the meter to measure your load consumption by putting CTs to the system, especially if you have if your premise is quite big, because the pass-through current is an 80 amp. So if your breaker is way more than 80 amp, then definitely you would need to use CTs. So this is the top part is an inverter, the 10 kilowatt inverter. Please take note that a 10 kilowatt inverter is split between 3 phases. So it's basically a 3.3 kilowatt inverter on each phase. So your load, when you're doing load specking for a 3-phase system, please take note of that. Make sure your peak power on each phase does not exceed 3.3. Because a 3-phase inverter, if one of the phases fails, the whole system shuts down. So please take note of that. And then just under the inverter, we have what you call the HV box, which is the high voltage control box. On this box, that's where all the terminations are done, and that's basically the management system for the whole system between the inverter and the batteries. So this unit is detachable from the inverter, unlike the SMAL 5. The unit is detachable. So all your battery cables, all batteries are connected in series up to 8 modules. The battery is in 48 volts, 56 Ah, like 51.2 volts nominal voltage. So all of them, they are daisy chain, they're put on a series, up to 8 batteries. But the minimum battery configuration that you can wire to the system, it's 4 batteries, because the minimum start voltage for the inverter, it's 180 volts. So definitely you would need 4 batteries as minimum, and then the maximum you can connect, it's 8 batteries to it. So all battery power is in series, wired to the HV box. Your PV array is wired to the HV box. The system offers two strings, 500 and 550 volt VAC 11 amps. The system can take PV of up to 13 kilowatt of PV can be wired to the system. And then you'd need to wire your comms cable daisy chaining the battery to the system. And then you need to wire your comms cable from the meter to the system. And then you need to wire the HV box to the inverter, the power cables and the comms cable to the inverter. So all the cables, they come with the inverter, and much of the cables, they are pre-installed. You just to plug it on the correct port. So the system working mode is the same as that of SMAL 5. The normal system with one inverter with PV to the inverter, it's a DC coupling with your grid meter, your normal loads and critical loads. And then if you have a second inverter without PV connected to the alpha, the system is an AC coupling. You would need a second meter wired to the inverter. And then for the hybrid system, it's basically an AC coupling with PV wired directly to the alpha inverter as well. So this is basically what we've been talking about. The top part is the inverter, which is the 10 kilowatt inverter, and then you've got your HV box, and then your battery modules, minimum 4, and then you've got an LCD display for local monitoring and control. The settings for the systems, they're basically the same with that of SMAL 5. Everything is the same. One good thing about the inverter, it supports unbalanced loads. So you can have one of your load around 2 kilowatt, other load around 500 watts, other load around 800 thereabout. And it also offers it also restricts individual phase fit in. So you can actually control your fit in such that each phase is controlled separately. That's giving it the ability to supply unbalanced loads. So the battery module, it's called M4856S. It's a lithium battery, just like Alpha with a longer lifespan of approximately 20 years as well, calendar year. It's a 95% depth of discharge, 2.7 kilowatt hour battery. It's a 1C. It's a 56 Ah battery. So you can actually draw 2.7 peak power from the battery at a core. It's a 1C battery. And then it has an integrated LMU. The battery uses a local management system, which is done by the HV box. So the system, it's a built-in system and a plug and play. So everything is pre-configured to it. So the battery has two comports for daisy chaining. You would have deep switches. So when you set up your battery, depending on the configure or how many batteries you have, you need to set your deep switches in a digital format. For each and every battery from number 1 to number 8, it's the deep switch setup is covered on the installer manual. And then the battery has an LED indication which comes on when the battery is in operation mode, and when it's off, it means the battery PM management system is actually off. The ring is green, flickering, but when it illuminates red, it means the battery has a fault, and you need to refer to the monitoring portal or the screen on the HV box to see what the fault is. And then obviously there's terminating points for your positive and negative. So the installation of it is basically the same as alpha. The covers for this T10, they are all detachable. So you can get, when you're installing, you need to remove the covers, mount the first battery, sit on the floor, and then secure with the bracket the second battery on top of first up until the fourth battery. And then a bracket is provided in which after your last battery, you just hook it to the top battery bracket, and then you can actually secure it. Once secured, then you can just hook the inverter on the bracket and secure it with side screws. Unlike alpha, the inverter doesn't physically rest on the battery. It's dependent on the bracket, so you would need to secure it. All your power connections are done on the inverter cable box. On the right hand side of the inverter, there is a connection box, more of a panel. This is how it looks like on the side of the inverter. And then on that control box, it has two breakers, which is your grid and your backup. So that's where you wire your grid input and your output to your backup loads. With this three-phase system, please note it's sensitive to phase rotation. So make sure your phases are wired correctly, the standard being red, yellow, or white, blue. So make sure they follow that sequence. If not so, upon power up, the system would give a phase angle error. Then you would need to swap around to make sure you get the correct phase angle. And then for the loads, it's a three-phase. You can wire them to three-phase loads, or you can supply single-phase loads. That is each phase considered as a single phase against neutral. Make sure your system is properly grounded. If not so, it will report a isolation fault. So the system comes with all the isolation devices pre-installed on the system. All you need to just pull your wires from your strings or from your grid and to your essential loads board. So basically, the T10 principle of operation, handling it, types of troubleshooting is basically the same with the Small 5. The system cannot be paralleled. It works as an independent. You cannot have two systems to carry 20. It's just a three-phase system. As I have said, I think I've been saying quite a lot of times during the presentation that on the backup loads, try and avoid inductive loads, because in most scenarios, maybe 8 out of 10 clients will be calling to say, we got load shedding and the system was continuously restarting. It wasn't giving output. It comes down to the speccing of the system. When it overloads, it will try and restart to check if that overload is still there. If it's still there, then you'll find it overloading continuously and all that. So try and avoid inductive loads, and try and avoid as well connecting DC loads on the AC bus. Let's say on the output of the inverter, then you connect a UPS. A UPS is basically a DC load, because it will take the AC out of the inverter, convert it to DC to charge those batteries. So if your battery bank is big, then you find a situation where the system gives you a DC high inject fault, to mean that on your AC load there is a DC component on it. So those are some of the things that you need to look at when you're speccing the system. So I'll quickly show you the monitoring portal. So this is the alpha. This is the alpha monitoring setup. Okay. So okay. So this is how as an installer. So after installing your system, if you are a first-time installer, you would need to contact us, and then we would generate what we call an alpha license. That is an installer's license. That's the one that you would use to. That's the one that you would use to register your system. So
sorry, Brian, your screen is still not, it's not shared. We're still looking at your presentation.
Okay.
Please stop sharing this screen and share the other one. Okay, great. We can now see.
Okay, sorry. Yeah, so this is the Alpha website. To access it, you just need to go to www.alphaess.com. So this is your home page. So if you are a new installer without an account, you have to register first. So you go to register. So this is the registering page. All you need to do, since you are an installer, you would need to select installer, and then it will prompt you for an alpha license. So if you are a new installer, you would contact us, then we'll generate an installer license for you. Please keep safe of this license, because it's needed whenever you install a system. So you would need that license. So as an installer, you are able to view all the systems that you installed under your name. So you'll be able to, with actually a better, you actually have a better view of every system that you installed, get to see the faults, you can actually do changes and all that, except for safety, which that is the grid code, you need to do it on site. So after you complete everything, prompt your username, your password, and everything, you submit, you get a success notification to say your account has been registered. Then you would need to log in into your account. So whenever you install a system, before you assign an account to the end user, you would need to register the system on your side, such that the end user will be able to view it, and you'll also be able to view it from your side. So this is basically how the Alpha website looks like. It looks quite nice. So you'd actually get to see the list of all the systems that you installed, the ones that are online, the ones that are offline. If a system has a fault, then you'd actually see a faulty system. If it has a protection, you can actually see which of the systems has protections. And then on the top window, you can actually access different modes. So the basic is the system mode. So on system mode, basically on default, it will show the SOD of the cumulative power drawn on the system. So for this system, as you can see, as of today, the system has produced 10.2 kilowatt units from PV. 5.2 were used to charge the battery, while its 4.9 went to the load. and the load it's 14.47 and all that. So you can actually get to see the real-time flow of the system, like how power is flowing at that instant. So for this system, the battery is at 100%. The load is 1,200. I'm sure the system is not set to feed back to the grid. That's why all the power is coming from the PV supplying the load. And then on power diagram, then you get to see the graph being plotted, which is power against time. So you get to see at the top, you get to see dial-ups. So in the middle of the circles, those are real-time values. So currently, the system is drawing around 900 kilowatts, and all of it is coming from the PV. The first one is PV, load, battery, feed in, and then grid consumption. And nothing is being consumed from the grid at this moment, and nothing is being fed back, and the battery is at 100%. And then at the bottom, you get to see the chart. So the green is for battery. So it means this system at night, it was supplying the loads with battery up until at around 3:40, it reached the reserve SOC set, which is, I think it's 60% because the part was around 59.6. And then since the installer set this percent on to reserve this battery for load shedding, at that instance, there was grid. So grid took over, started supplying the loads during this period. The battery continued at 59 up until 6 in the morning when, if you see from 3 to 6, the grid was matching, the grid matched load. But as soon as the PV coming up, the PV started dropping because some of the power was now being supplied by the load. As I have said, the system operation, it first uses your PV to supply your loads. Once all your loads have been catered for, from there charges your battery. Once the battery is catered for, then it fits into the grid. So you would see that from there it started to, when PV started rising around towards 8, the PV power was quite high. It was able to supply the loads. None of the grid was being used, so the PV was supplying the loads, and then the excess of it used to charge the battery. You can actually see the battery SOC started rising up until around 11:10. From there, so you would see a small trickle power that's feeding to the grid. This is common in scenarios where you have spiking loads. If your load profile is spiking, you have pumps, all of a sudden they're drawing 5 kilowatt, they just drop to 500 watts. So the inverter uses a set point follow load scenario, kind of. So the meter has to first measure all your loads, and then it gives the set point to the inverter will produce. So the loads were at 5 kilowatts, the system was producing 5. All of a sudden they drop to 500. So by the time the meter detects that the load has dropped, and then the inverter has to ramp down. That gets to be done within two seconds. But obvious, there is that hysteresis, that 2-second hysteresis causes a trickle power, which would flow back to the grid. It's not considered as feed-in under NRS 97 if it doesn't run continuous for a minute. So it's just a pulse power due to hysteresis that flows back to the grid. So usually, if you have with some digital meters with low reverse current tolerance, you would get them tripping here and there. So you would need to contact us, especially if you have a con lock. That's the one which usually trips because of its sensitive reverse power current. You would contact us, then we would actually file with Conlog, and then they can widen the tolerance of your meter such that it doesn't trip on that trickle power. Or alternatively, you can strike a balance between your battery SOC and your PV array to avoid that trickle power, because the trickle power happens when the inverter is when the inverter battery it's full. Let's say just above 95%, where the battery management system will be performing what you call trickle charging, not so as not to damage cells. That's where usually you get those trickle power. And then the next setup will be the statistics. So it can actually show you how much power you've been using, how much were loads, how much PV power you generated throughout the month, year, and so forth. This is basically statistical. And then if you have set your tariffs correctly and all that, it can actually calculate your savings if you were to buy that power from the municipality. And then on the system page, you get more functions. That's where you can, basic functions, that's the basic system information. And then you get the inverter information, that is the number, the inverter installed, the PV size installed, and all that. And then from there you can get the battery information. So on the battery information, you actually check how many batteries you have and the total capacity. So you can, for this system, he has 2 batteries, you get the serial numbers automatically picked, and then the capacity of it, and then the meter information, software versions. That's where, on electric tariff, that's where you set your different tariff for different tariff zones. And then if you go through, you have the charging and discharging, which is the most commonly used. So on this one, you can set your inverter to charge. So you get 2 charging periods, which is you can set it to charge for a certain time from certain period of time, and then you can get it to charge maybe in the morning on time 1, in the evening on time 2. You can set it to discharge for certain periods of time, with preferential. So this system is set to discharge the battery only at 12 to 4. Usually we don't recommend setting this, putting up this setting, because once you do so, if you have a load shedding out of the system will not supply your loads. So usually we prefer you leave the charge setting set to 0 zeros and deactivate it such that the system can discharge throughout the day. And then on discharge card SOC, this is the reserve SOC, so you can change it remotely to whatever percentage you want. As I've said, this system is set to reserve 60% of that, of the battery. And then other scenarios, and then if you are using aux contacts, then you can configure them there. And then the other one is the other information. So on other information, basically you get the system overview, your system, which type is it set to, is what mode is it working on, and all that. And then one of the important setting under set other information is the maximum fit in rate. So on this setting, that's where you would set your amount of power you'd want to feed back to the grid. If you are not to feed back to the grid, you select 0. If you are to feed back to the grid, depending on how much power you want to feed back to the grid, you can calculate it as a percentage of 5 kilowatt, and then you can put that setting there. So, and then on installation record is basically the basic information, address and contact person of the system owner. And then on running info, this is a handy tool for installers. So on running info, basically it logs everything that was happening on the system. Even if you change a settings or someone logs in to view the system, it will actually log it. But the tool that we usually look at as installers is the fault. So on running info, you select fault. So on fault, you get to see the type, the fault codes, and the period and the time period that it happened. So in this case, you can guess the system got an OCP fault. So basically, an OCP fault, it's the battery was overloaded during that time. One of the batteries had, well, much power of it was was drawn, and then it was, and then it gave that fault. So you would get to all the faults logged for different times, and then you can actually help you to troubleshoot, and then you can just scroll to check for all the different types of faults that happen to the system, so that whenever you are going to site, you are already trying to find the solution in your mind, and all that. So basically that's much of it in terms of the monitoring portal. So to register the system, sorry, I forgot. So once you have installed the system, you log in into your account, then you go to system storage maintenance, and then you select install new system. So it will open up another page. So here basically you would need the serial number of the system that you installed. Under the serial number there is a code. It's either written verification code or check code. That's the one that you input here on check code. And then you would need to input your license number. So your license number basically assigns that specific system to your account, so that you'll be able to view it. At the same time, as Alpha, if we assign a license number to you, and if you register the system with that license number, then we'll be able to monitor and to monitor your system. In case it is a fault, then you can quickly log in and check from our side as well. So once you fill in the details and save, the system would appear on your will appear on your list of systems here. So basically that's that's everything about the monitoring portal. And then Alpha have an app which is, you can download it from Play Store or Google Store, which is just type in Alpha ESS. It has this A, so you can actually view your system or through the app, and do all the changes that you could do on the monitoring portal on the app as well. So basically that's all for our training today. Are there any outstanding questions on the chat box?
No, I think I responded to most of the questions. I don't know if there are any questions that are arising that you want us to respond to. The floor is open. You can just unmute your mic and then ask the question.
Hi guys, can you hear me?
Yes, hi Daniel, can we hear?
All right, perfect. Hi guys. Just a quick question. Can you integrate a second system? For example, if we use a 10 kilowatt 3-phase hybrid machine, can you integrate, for example, a Fronius grid tie machine in front of it, so that the Fronius feeds back into the Smile, so that we don't utilize the battery throughout the whole day? So the panels rather produce power into the grid or the household, and then obviously when load shedding comes or nighttime comes, then only the batteries start feeding into the 3 grids. If my question makes sense.
Yeah, I think you are referring to an AC coupled system. I think where you've got in distributing the Fronius, and then we are using the Alpha system as the backup system, where if there's load shedding, the Alpha takes over. So the point that Brian also made that is important, if you are going to be using such a system is the alpha system. The alpha systems don't offer the term just goes away from frequency shift. The PV inverter will fall off, and then you'll just have the picture there on the screen. You just have the alpha supplying your backup loads, but there is no direct communication between the alpha inverter and your PV inverter. I don't know if I'm.
No, no, I'm happy.
I can't hear you. I think you have to unmute your mic.
No, no, I'm happy. I understand what you're saying. And tell me, is the alpha machine itself
okay. No,
compatible
that's
with?
fine.
Is the alpha machine compatible with different battery sets? For example, if we implement super caps, the new super cap batteries, will that also be able to comply with the alpha machine?
No, the alpha unit comes as
No,
a.
it's strictly
Its own batteries.
no, it's strictly. Sorry. Yes, it's its own battery, because the BMS it only integrates with the alpha battery. It's not configured to, because it's a fully integrated system.
Okay, no problem. That's it. That's my questions. Thank you, guys. I appreciate it.
Thanks, Daniel. I don't know if there are any other questions. Okay. So if there are no more questions, I would like to thank you for attending the training. So we are going to be uploading this webinar on our YouTube channel. We'll share the link with you in our follow-up email.
Brian?
Yes.
Please feel free to contact us as technical support, or to contact any of your account managers if you've got any other questions. So we have got these rolling webinars going every Thursday at 10:30 for different products. So please feel free to if you don't get an invitation, to contact me or to contact any of your account managers. Yes, Sabine, you're saying something?
Guys, I just need to ask a question quickly, if you can hear me.
Yes, is
Okay.
Sonnet.
If you install the
I
5
think
kilowatt small
there's
5 system with the
nothing else.
5 kilowatt battery, can you use the 10 kilowatt with that 5 or not?
No, you cannot. If you have 5 kilowatt battery, you can only loop together 5 kilowatts. If you have a 10 kilowatt, you can only loop together a 10 kilowatt.
Okay.
No.
Thank you. That's all. Thanks, Brian.
Okay, cheers. Is there any other question?
Yes, there's just last one. Is these coupons that you guys are mentioning here, are they only valid for a certain amount of time, or not?
They are valid until the 31st of May, and it's with every system you buy that's including the 2 batteries.
Okay, perfect. Thank you.
If you don't have any other questions, Thank you everyone for attending. We'll be rolling out these webinars next week. We'll be having a webinar on genset integration in Combi. I'm sure a link will be shared with you. We'll also hold another alpha session in March. A link will be shared. Thank you everyone for attending.
Thanks, Brian, and thank you for all your help and with my systems in the past. I really do appreciate it.
Thanks, you're welcome.